Thank you for joining this lesson. We're going to discuss logarithms. In number 12, we are told to solve for k in the equation. The logarithm to base 3 of k squared equals to half the logarithm to base 3 of k plus 3 out of 2. Remember to subscribe to this channel and to also share the link with friends. So what we are having here is a logarithm equations, and we are to find the value of k. So the first thing I would advise you to start with is, because the logarithm to base k, or the logarithm of k to base 3 is appearing at this point and also at this point, we can let it be a different unknown. We can let the logarithm to base 3 of k to be a certain unknown, let's say y. So that at this point, we say we have y squared. This is equivalent to half the value of y plus 3 out of 2. Okay, we can eliminate the fractions by multiplying through by 2. So that by 2 we get 2y squared equals to y plus 3. Then we rearrange the equation now so that it may take a quadratic shape. That means we start with the squared part, then followed by y, then followed by 3, so that we remain with a 0 at this point. And with that, we can solve for y, whereby I choose to solve by the factorization method. A product of AC, that is 2 by negative 3, giving us negative 6, and a summation of B. The value at B is a negative 1. So we need two factors whose product is negative 6 and the sum is negative 4. That is none other than a negative 3 and positive 2. When these are multiplied, they give us negative 6. When the two are added, they give us negative 1. So now we have to replace negative y with negative 3y and negative 2y. Okay, positive. That means we need 2y squared. Then I subtract 3y and I add 2y. This is now what is substituting negative y. Then less 3 is equivalent to 0. So now we factorize what is common. In the first two terms, we have y being common. That means we remain with 2y minus 3. Then in the second two terms, or the other pair of terms, we're going to have 1 as the only common factor. So that will remain with 2y minus 3 equals to 0. So now we will have the common factor, which is 2y minus 3. Then y positive 1 is the other factor. This is equal to 0. So this means now we can solve for y and say that 2y minus 3 equals to 0. And that means the value of y is equivalent to, when we take y to the other side, we're going to get okay, we can remain with 2y equals to 3. So that will remain with y. We need 3 out of 2. And y is also equivalent to, we take 1 to the other side, so y is equivalent to negative 1. Now that we have solved for y, and remember, it is the log of k to base 3 that had been let to be y, then now the k can be solved. So we need to say the log to base 3 of k is equivalent to 3 out of 2, and also the log to base 3 of k is equivalent to negative 1. We know very well that these are logarithm equations, and they can be changed to index notation, whereby generally we say the logarithm of b to base a equals to c, means that when we take a power c, we're supposed to get b. So this is index equation, and this is the a logarithm equation changed to index notation. So this means in the first case, when we take 3 power 3 over 2, 3 power 3 over 2 should give us the value of k, and also 3 to the power of -1 should also give us k. So we have two values of k. The first value, when we raise to a negative power, we just need to take 1 out of 3. This one is equal to k. So the first k from this second value is going to be a third. So the value of k is a third. And in the second case, we need to take 3 raised to 3 over 2. That means we need to take the square root of 3, then we raise to power 3. This gives us a 5.196. So the other value of k is 5.196 for significant figures. So we have this value of k and a third as a value of k.